Today we're going to talk about Unit 1, Lesson 3, Simplifying Radicals. Basically, a radical is a square root. You could have a square root, you could have a cube root, a fourth root, a fifth root, whatever the index number is indicates how many times or how many factors of the same number you need before you can bring something out. You should be fairly familiar with square roots and cube roots. We'll go into a little bit deeper with Algebra 2. Basically, the first thing you really need to be familiar with, now I know you have a calculator, but there are some square numbers and cube numbers that you really just need to be familiar with so that you're using that calculator as a tool, not a crutch. It's really important that you have basic number knowledge, like your multiplication tables and so forth, to be able to get through your Algebra 2 course more efficiently, okay? So I've made a list here of your basic numbers. I've just basically gone from 1 to 15, and then 20 and 25 show up a lot with square numbers, so I added those. And then I've got that number squared, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. And you need to be familiar with the square numbers 1 through 15, 20, and 25. Those are the ones that show up the most often, so it would help you to work more efficiently if you know those off the top of your head. Your cube numbers, in other words, what numbers multiplied by themselves 3 times would give you the number. So like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And for your cube numbers, it's good to be familiar with at least 1 through 10. I'm just going to do a few things to review before we get into the new information. So if in Algebra 1, you may have been asked to take the square root of a number. And for the most part, they just, in Algebra 1, wanted you to take square roots of square numbers. They may have done a little bit with simplifying non-square numbers, but that's at the very end of the course, so you probably didn't get very far with that. But basically what a square root means is they're asking you what times itself will give you the number that's underneath that square root. Now, with this is your square root symbol. If there's no number right here, then that means your root is 2. In other words, you need 2 factors of the same thing to be able to bring it out 1 time. And there's a whole bunch of different ways you can simplify one of these, but basically 64 is a square number itself. We know that 8 times 8 is 64. So the easiest way to do that is, if you know your square numbers, you're just going to put 8 down for that. Square root of 81 is 9. Okay? Now there's another way to do that by breaking the number down if you don't know what your square numbers are, and that's what we're basically going to learn in this lesson. A little bit more review before we get into the new information. Absolute value is going to come up in this lesson, so I want to make sure you remember absolute value from your Algebra 1 knowledge. The absolute value definition is the distance a number is from 0 on the number line. Okay, and if you think about that, basically, if this number line is drawn accurately, now I drew this by hand, so it might be off by a tad, but let's just say I have 3 and I have -3, both graphed on my number line. If the absolute value is the distance a number is from 0, that means that your distance is how many spaces you are from 0 on the number line. And if you think about distance, and this is where some students get absolute value confused. If you think about the distance a number is from 0, we don't account for negatives. We don't account for whether we're going right or left, okay? So the distance between 0 and 3 is going to be 3, and the distance from 0 to -3 is also 3, okay? Since distance can't be negative, and absolute value represents a distance, absolute value can't be negative, okay? Now, that's not to say that you can't ever have an absolute value problem, like a problem that has absolute value in it, and say you can't ever get a negative. That's not quite true. I'll show you an example. But basically, the absolute value symbol are just 2 kind of slanted lines around what you're trying to what you're trying to get the answer for. So this is the absolute value of 6. Well, the absolute value of 6, the distance 6 is from 0 on the number line, is 6. Now, if you have something like this where you've got math inside your absolute value, what you're going to do is you're going to do the math problem first. So 2 minus 10 is -8. And then I take the absolute value of that answer. So the absolute value of -8 is 8. Now, what if I have something like this? What if I say the absolute value of 2 minus the absolute value of -7? Just a real simple example. Here, my math operation is between the two absolute value symbols. So here, I need to take the absolute value of each number first. So 2 minus the absolute value of -7 is 7, okay? And so 2 minus 7 is -5. See, we started with some absolute values, and our answer ended up being negative, but we are not saying here that the absolute value of anything is negative. The absolute values were both positive, but then we had to do the math in between. So you could have an absolute value problem and have a negative answer, but the absolute value of no number will ever be negative, okay? The next thing, it was multiplying monomials. As we're getting into simplifying radicals, we're also going to be simplifying radicals that involve variables. So if we are simplifying variables, we need to understand how the exponents for variables work when we're dealing with multiplying monomials together. So basically here I have two monomials, x squared times x cubed. And you should have learned in Algebra 1 that if you're multiplying x squared times x cubed, basically what that means is x squared means you have 2x's, and x cubed means you have 3x's. And if we're multiplying those together, then we have a total now of x to the 5th. And then hopefully your teacher taught you that since that happens, basically what we're doing here is when we have two monomials with the same base, we're going to keep that base, and what we're going to do is we're going to actually add the exponents together. So when you multiply monomials, you're actually adding the exponents together. And this will be significant when we get into simplifying radicals, because if you don't understand that concept, it makes it really difficult when you're dealing with variables within radicals. Looking at this one, a cubed times a cubed, well, that would be a, we keep the base, and 3 plus 3 is 6. Now, if you think about this, talking about square numbers, okay? A cubed times a cubed, hopefully you recognize those are the same, okay? So if I multiply those together and get a to the 6th, a to the 6th is actually a perfect square because I multiplied a cubed times itself to get a to the 6th. So notice the perfect square in variables doesn't have to be a square number for your exponent. Your exponent has to be even in order to have a perfect square dealing with variables. And that becomes very important when you're simplifying radicals. Looking at this one, y to the 5th times y to the 5th equals y to the 10th. We keep the base and add the exponents. So y to the 10th is a perfect square number because the square root of y to the 10th would be y to the 5th. Okay? And there's a little bit more detail in that as we go further, and we'll talk about what that means as we're getting into radicals. So if you look here, I've asked you for the square root of x to the 8th. Well, what I'm asking for there is what do you multiply times itself to give you x to the 8th? How many x's do I need to go right here in order to get an 8? Well, we know they have to be the same, so what plus itself equals 8? Well, that would be 4. Okay, so if we break that down, that's the same thing. So my answer, that shows up twice, my answer would be x to the 4th. So think about it. What do you think this one would be? The square root of a to the 20th would be, hopefully you said, a to the 10th. Okay, so that's our review for this section. Now we're going to get into dealing with the new information. All right, so let's get into the new stuff for section 3. The first thing I want to show you is the parts of a radical, just so that you understand the terminology when I refer to certain things. The radical sign, of course, is this square root symbol here. That's called the radical sign. There sometimes will be a number right inside the little radical symbol. And that number is called your index number. Now, if there's nothing there, like it looks like this, then the index number is understood to be a 2, so it would be a square root. For all other radicals, there would be a little number in there. So like if it's a square root, they're telling you how many times does something show up twice. If something shows up twice, I can bring it out 1 time. For a cube root, it has to show up 3 times to be able to bring it out. For a 4th root, it has to show up 4 times, and so on. So a 5th root, 6th root, and that number can really be anything, but the larger it gets, the more complicated the math becomes. So we tend to not go past 5. Later in the year, we'll learn about fraction exponents and how to deal with those and how to convert them to radical signs. The number or the expression inside your radical sign is called the radicand. So if I use that word, you know that's just the expression inside. Okay? Next, I'm going to show you how to break down some simple radical signs or radical symbols. We're going to start with square roots. We're going to start with just numbers, no variables, and see so you can see the basics of this. And then we'll get into the more complicated problems as we go. So the first thing I'm going to do, if I look at this, it says a square root of 180. The first thing I'm going to ask myself is that a perfect square? If it's a perfect square number, then I know the answer, I'm done. Okay, so like if it were the square root of 100, I'd say, well, the answer is 10. It's finished. Okay, but 180 is not one of our square numbers, so we have to know how to break that down. So this is where your division rules come in handy. Your let's see, your divisibility rules. So that's even, so I know 2 goes into it. Okay, 3 would go into this because if I add all the digits together, 1 plus 8 is 9, plus 0 is 9, and 3 goes into 9, so it has to go into the whole full number. The divisibility for 4, if the last 2 digits are divisible by 4, like 80 is divisible by 4, so 4 goes in there. If the number ends in 0 or 5, it's divisible by 5. For 6, if 2 and 3 both went, 6 will go. 7, there aren't really, you have to pretty much divide that one out. There's not a whole lot to do there. But for those 1 through 6, you have some really good divisibility rules to use. Plus 10, if it ends in 0, you know 10 goes into it. Okay, so the best thing to do, I have a lot of students who always use 2. So like they would break it down, say 2 and 90. And then they do 90, and they'd say, well, 2 and 45. Well, the more you use 2, the longer these problems are going to take. So your goal, especially as you're getting into the higher math classes, our goal is to work as efficiently as we can, because a lot of your testing that you do, your SAT and some of your placement tests in college are going to be timed. So if they're timed tests, you want to work through these problems more efficiently. And so that's what we're really trying to get you to do in Algebra 2, more so than we did in Algebra 1, okay? So if I'm looking at this, I know 10 goes in because it ends in 0. So I'm going to use 10 anytime my number ends in 0. It just makes it a lot easier. And 10 times 18, I know, is 180. So right there, I've broken that number down into some really, really simple things to use. 10 breaks down to 2 and 5. 18 will break down into, I could use 3 and 6. I could use 2 and 9. And then 6 goes further into 2 and 3. Okay? So what I'm going to do is I'm going to break that number down until I get number doubles. Okay? In order to simplify this radical, anything that shows up twice, I can bring outside of the radical 1 time. Okay, so if I look at this, 2 shows up twice. So that means I'm going to bring out 1, 2. Okay, 3 shows up twice. So I'm going to bring out 1, 3. Now, the numbers that I have on the outside of my radical, I don't say that's 23. I'm going to multiply those 2 numbers together. So I've got 2 times 3 on the outside. And then on the inside, I'm going to put any number that didn't have a double. So the only thing here that doesn't have an extra number with it is a 5. So I'm going to bring down my 5. Now, when I tell you that, I'm looking at the very lowest breakdown of my numbers. Some people might mess up and put 6, but 6, remember, broke down into 2 and 3. 5 wouldn't go down any further. That's why I'm including it underneath the radical. So my answer here would be 6 square root of 5. Now, I do want to caution you on one thing. There are some calculators out there that will do this for you. You can type in the square root of 180 and it will give you 6 square root of 5. But if you use that calculator to do that for you and you don't learn this process, it is going to set you up to really struggle when we get into imaginary numbers, okay? So make sure you're practicing some of these by hand. If you don't, fair warning, it's going to get more difficult later, okay? So make sure you're practicing that. All right, 245, square root of 245. If I do that one, well, it ends in a 5, so I know 5 goes. So if I put 5 into there, let's see, that's going to be 49. Now, if you don't know that, that's okay. Use your calculator. Just use your, a regular 4-function calculator is all you need for this. So do 245 divided by 5. It'll give you 49. So you know that breaks down into 5 and 49. 5 will not break down anymore. 49 does. 49 goes down into 7 and 7. Well, that right there gives me a double number. 7 is a double number. So I'm going to bring out the 7, and then that 5 stays underneath. So we have simplified that. Now, understand, for a lot of these, there may be more than one way to do them, and that's okay. You might get your answer a different way than I did, but it should still give you the same answer that I got. It's going to depend on what you choose and how you choose to break down the numbers. If I get going too fast, just pause the video, rewind it, go back, and re-listen to what I'm doing. Please make sure you're taking notes. It's going to help you. Helps brain function if you write things down. Okay, so write it down, take good notes, have these in your notes so you're not having to go back to the video every time you have a question. You have something to look at in your notes. All right, you might have a radical that it contains a fraction. Okay, when that happens, you are allowed to break down fractions that are within radicals. So that square root of 9 over 25, that is the same thing as the square root of 9 over the square root of 25, okay? You never want to put the square root of 9 over 25 in your calculator and hit equals. It's probably going to give you a decimal, okay? We don't want decimals for these answers. We want answers in simplified radical form. And as I go through more of these examples, you understand what I mean by that. All right, so with this, now that I've broken it down, I'm just going to simplify the top and the bottom. And then if it can be simplified further, I'll simplify that fraction. So the square root of 9 is 3. The square root of 25 is 5. So the answer there is 3/5. For this one, the square root of -8. Now let's think about that. Is there any number that I could multiply times itself to give me a negative number? Now, hopefully you're saying no, because if a negative times a negative is a positive, and a positive times a positive is a positive, and we're looking for a number that is the same thing to give us a negative number, it's impossible to have 2 positive numbers give you a negative or 2 negative numbers give you a negative when you're multiplying, okay? So that right there is not going to be possible, at least not yet, not until we get into the imaginary number system, okay? So for now, you're going to say no solution for one of those, okay? We'll get into more of that later. I think it's chapter 5 or something. It's a while. The next one. Here we have a cube root. So if we're looking for a cube root, now my number has to show up 3 times before I can bring it out, okay? So now I've got 128. Let's see. I know 2 goes, but let's try something a little bit bigger. I'm going to do 4, because 4 goes into 28 7 times, so I know 4 will go into that. So I'm going to break it down. 4 goes into 12 3 times, 4 goes into 8 twice. So that's 4 times 32. 4 breaks down into 2 and 2. 32, I know that's 4 and 8. And then this 4 breaks down again into 2 and 2. The 8 breaks down into 2 and 4. And my final 4 breaks down into that 2 and 2. So I have 1, 2, 3, 4, 5, 6, 7 2s there. Well, my index number is a 3, so that means anything that shows up 3 times can be brought out 1 time. Okay, so for every 3 2s, I'm going to bring it out once. So I can bring out 1 2, and then 1, 2, 3. I can bring out another 2. And I have that 1, 2 left over. That one will go inside my radical. Make sure if you start with a cube root, you still have a cube root here. Don't leave out the index number. And so that's going to be 2 times 2 is 4. That's 4 times the cube root of 2. Now, if you think about that, 128. I'm going to do that again over here just to show you something. If I recognize that that's 2 times 64, and I remember back to that list at the very beginning when I had the list of the cube numbers, that was the cube of 4. 4 times 4 times 4 is 64. So we're right there. I could have said, oh, that's 4 times 4 times 4. I'm going to bring out that 4, and that leaves me with the cube root of 2 inside. Okay? So there's going to be a whole bunch of different ways to do these. There's not one best way. Whatever's best is whatever way works for you, where you get the right answer. Okay? It might take you longer some ways, but it doesn't matter. I want the right answer. All right, the fourth root of 32. 32, 4 and 8. 4 breaks down into 2 and 2. 8, I'm going to go ahead and say that's 2, 2, 2. 2 times 2 times 2. You should be familiar with that. And then anything that shows up 4 times can be brought out once. So there's 1, 2, 3, 4 2s. I bring out the 2. That 1, 2 is left inside. All right? And then last, the fifth root of 96. Well, if I look at that, 3 goes into there. 3 goes into 96 32 times. And that 32 keep showing up. So that's 4 and 8. 4 is 2 and 2. 8 again is 2 times 2 times 2. And this time it has to show up 5 times to be able to bring it out once. And so look at this. 1, 2, 3, 4. I have 5 2s. I bring out the 2. I keep that fifth root of 3. And look here, I made the mistake I told you not to make earlier. The fourth root, that's a fourth root. I need that fourth root right there. Okay, you see how easy it is to forget that. It's very simple to forget that root number. So you just have, that's one of those things you have to be real careful about the details. All right? Okay, we talked about what happens when you have a square root of a negative number, that we had to put no solution at this point. But we didn't talk about what if you have a cube root of a negative number. If you think about it, when we're talking about the cube root of something, we want something that multiplies by itself 3 times to give us the number inside the radical. So if you think about that, pretty much anytime you have a negative number, well, anytime you have a negative number underneath an odd index number, you could consider that you have a -1 times whatever that number is. And the odd root of -1 will always be -1. So if you think about that, -1 is -1 times -1 times -1. So we could bring that -1 out, no matter what the root number is. That could be a 5, that could be a 7. It doesn't matter. As long as it's an odd index number, you could bring the -1 out, okay? And then the cube root of 64 is just 4. So -1 times 4 is -4. Now, another way you can think about that is if you break down -64 into 3 negative numbers. -4 times -4 times -4 is -64. So the cube root of -64 is just a negative number, okay? So you can do that with pretty much any negative number as long as the root is odd. What you need to distinguish, though, is if the root is even, if your index number is even, you cannot have the root of a negative number. It doesn't work. You'd have to put no solution for that. So that's a little change between your odd and your even index numbers. You have to be real careful there, understand the difference. All right, so now with this one, I've added some variables. I want to know what happens when I take the square root or the cube root or the fourth root, dealing with variables, okay? So looking at this one, I know that the square root of 100 is 10, so I know I can bring a 10 out. And then I have to ask myself, well, what do I multiply by itself to get x squared? Well, if you think about that, x times x is x squared. So the square root of x squared is just x. You will notice as we go through this unit that an index number, a square root, and a square kind of undo each other. They are the inverses of each other, so they undo each other. So if you have the square root of a square, then you just end up with your x value. If I have the square root of something like 3 squared, well, that would just be 3 because the square root and the square undo each other. They cancel each other out, okay? And then for the y to the 6th, well, think back to when we reviewed multiplying monomials. We said that if we're taking the square root of an even index number or an even exponent, then what can we add to itself to give us 6? Well, it was 3. Y cubed times y cubed is y to the 6th. So we have 3 y's that will come out. Now, another thing you could do for that, if you don't like thinking about it that way, well, you could just take the index number and you could divide it into your exponent. So the index number here is 2, so 2 divided by 2 is 1. There's 1 left over, 1 coming out. 6 divided by 2 is 3, so we take 3 out, okay? Now, another thing you need to understand with exponents being underneath there, when we take out variables, we have to account for whether that variable was positive or negative, okay? If it was a negative number that was squared, well then, even if we take the square root of that negative number squared, it will be positive. If we take, like if this y had been a negative number, okay, well, taking a negative number to a 6th power is going to make it positive. So whenever we start with an even exponent within the radical sign, when we take out what we can take out, if we end up with an odd root or an odd power there, what we have to do is we have to put absolute value around it, because since what was here had to be positive because it was an even exponent, what we have left also has to be positive because we know that number had to be positive to begin with. So that adds kind of another dimension there. If you start with variables that have even exponents inside your radical sign, and when you bring them out, you end up with odd exponents, then you need absolute value around them. Okay, now if you start out with an even exponent inside and it comes out and it's still even, you don't need absolute value because an even exponent is going to make it positive anyway, so that the absolute value becomes redundant at that point. Okay, so let's do another one. Here, as we said before, we said that a square root and a square undo each other. So if I have something like this, the square root and that square undo each other, all I have left is x plus y. Now I have to think about it. I started even. This ends up being to the 1st power, so I would need absolute values around that. Anytime it goes from an even power to an odd power, I need absolute value. And then let's look at the last one here. For this one, I'm going to break things down, and I'm going to bring out what I can bring out, and then see what happens with my variable. So I'll do the number first. Well, 120, that's 12 times 10. 12 breaks down into 3 and 4, 10, 2 and 5, and then 4 breaks down into 2 more 2's. So anything that shows up twice, I can bring out once. So looks like I can bring out a 2. And then I have a 3, a 2, and a 5 left. Well, 3 times 2 is 6, 6 times 5 is 30. So it looks like I'm going to have a 30 left inside. That doesn't break down any further. And then I can do my variables. Well, look at this one. X cubed, that's not even, okay? So I need to determine how many I can bring out. Well, remember, if it shows up twice, I can bring it out once. Well, if you think about x cubed, that really means I have 3 x's. Well, I can bring out anything that shows up twice, I can bring it out once. So I can bring an x out, but that leaves me with 1 left inside. Now, an easier way to do that, I think, remember we said the index number can divide into the exponent here. Well, if you take 2 into 3, it goes in once. We bring that 1 out, and then there's a remainder of 1. That 1 remainder stays inside. Okay, so I can do the same thing here. What is 4 divided by 2? Well, 2. So I can bring out y squared. And then for this one, how many times does 2 go into 5? Well, it goes in twice. So I have a z squared, but I have a remainder of 1, so that a leftover z stays inside. Now, anything that went from an even exponent to an odd exponent will need absolute value. So let's look. That started odd. We don't need absolute value. That started even. Did it end odd? No, it didn't. That started odd, so we don't need any absolute value in that problem. Okay, I've got a few more examples real quick. Here, that is x squared over 36 all underneath the radical. So I can simplify that or break that down into the square root of x squared over the square root of 36. The square root of x squared is x. It started even, ended odd, so I do need absolute value. The square root of 36 is 6. So that's all we have to do for that one. Looking at this one, that's just something different I wanted to make sure I mentioned to you. If you have a plus minus in front of your radical sign, whatever sign is in front of it has to stay with the answer. So if it says plus minus square root of 36, the answer would be plus minus 6. Whatever is here just goes in front of it. So if I had like a negative and then square root of 8, well, with that negative comes down. I keep it. I know 8 is 2 times 4, and 4 is 2 times 2. So I can bring out a 2. The negative stays in front, so that's negative 2, and then left inside is the square root of 2. So that's not any different than what we did. We just have to tag that negative in front. Whatever's in front stays with it. For this one, the square root of 9 is 3. The square root of x squared is x. If I take 2 into y to the 5th, I can bring out 2 y's. I still have 1 left inside. And then take the 2 into the 8, I can bring out 4 z's. Whoops, that's supposed to be 4. And next I need to check for absolute value. Anything that started even and ended odd needs an absolute value. So the x exponent started even. It ended up being odd, so I need absolute value around the x. That started odd, so I don't need absolute value. That started even, but ended even, so I don't need any more absolute values there. Okay, looking at this one, the cube root of negative 125. Well, we know if it's a cube, an odd root or an odd index, we can bring the negative out. So we're bringing out the negative. The cube root of 125, we should know is 5, so we can bring out the 5. And then to do my variables, I'm just going to take the index number into each of these, and then the remainders will be left inside. So 3 goes into 4 once, so I can bring 1 out. That leaves me with 1 inside. 3 goes into 6 twice, so I can bring out 2 b's, no remainder. And then 3 goes into 8 twice, with 2 left over. So those 2 were left inside. It was a cube root, so I keep the cube root. And absolute value, if it starts as an odd root or an odd index, we don't need absolute value. You don't have to account for that. We only do absolute value when we have an even root. Okay, my last 3 examples of these type. If I'm doing the cube root of 16, I need to break down 16. I know 16 is 4 times 4. And again, there are many different ways you could break down 16. You don't have to use 4 and 4. So I end up with 4 2's, so that means I can bring out 1 2, because it has to show up 3 times to be able to bring it out once. I do still have a 2 left inside. 3 goes into 13 4 times, so I can bring out 4 x's. The remainder is 1, so I have 1 left inside. 3 goes into 7 twice. I have 1 left over because the remainder of 7 divided by 3 is 1. And then 3 does not go into z to the first. Nothing comes out of the z. It has to stay inside. Sometimes that will happen. Absolute value, we don't need any because we started with an odd root. For this one, just like square roots and square exponents cancel each other out, the cube will cancel out the third power. So The cube root of -4 to the third is just -4. The fifth root of 2 to the 10th, well, you could expand 2. You could do 2 times 2 times 2 10 times and get a huge number and then break it down. But if you think about it, if you break that down, isn't it just going to be 2 times 2 times 2 10 times? So there's no need in doing all that extra work. Your exponent here can work just like your exponents with variables. I'm still allowed to divide 5 into the exponent 10. 5 goes into 10 twice, so I have 2 to the second power, which is 4 for my answer. So sometimes it's easier not to do the math. It's easier to just cancel out your exponents and your index number and not have to expand your number out completely.